Hello guys, I'm so glad that you joined us once again in our sessions, our revision sessions, where we're looking at past paper questions and getting you guys ready for your exams. We're still busy with paper 1, and today we're going to look at a section that's a very big part of paper 1, and that is calculus. And calculus combined with functions is really the biggest section that you're going to be looking at, or the biggest sections you'll look at in your paper 1 exam. So calculus and functions, make sure you understand those two concepts extremely well. And remember, what I always say is practice, 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 not until you get it right, but until you can't get it wrong. But guys, I really urge you at this time of the year as well to be very kind to yourselves, and when you have practice to the point when you cannot get it wrong, then remember to reward yourself. So this is different things for different people. Maybe for you it's a chocolate, maybe it's an extra half an hour in your break during your exam study period. Whatever it is, keep it good, keep it clean, and reward yourselves when you've practiced. Remember to reward your hard work. Now, the CAPS breakdown for exam purposes, differential calculus is 35 to 38 marks in your final exam paper 1. It accounts for roughly 25% of that paper. The key concepts that we look at when we do calculus revision is differentiation, cubic graphs, and optimization problems. Now, with differentiation, you need to know how to derive both by first principles and by rule. You cannot leave the first principles section out of your studies. You need to know how to derive by first principles. And you also, cubic graphs make up a huge section of the calculus part of your exam. So you need to understand how to interpret cubic graphs and also how to sketch a cubic graph. All right, so the first question, and this is generally when your exam is set up, you will see that in your calculus section, the first section that you are tested on is usually deriving from first principles. So that's where we're going to start today's lesson. And this question comes from the DBE June-July 2015 paper. It's question 8.1. If you are revising along with your exam papers while you're watching the show, then that's the paper that you need to look for. Alternatively, you can just copy it down from the screen if you don't have that paper with you. Okay, so we're going to start by determining by first principles, determining the derivative from first principles. You've got the function f of x is equal to 4 over x. It's for 5 marks. I'm going to give you guys just 2 minutes to attempt this by yourselves. Write down what rule you're going to use and how you are going to set up your first principles. I'm going to give you, as I said, 2 minutes. Okay guys, so let's go straight to the question. We've got a lot to get through in today's lesson. So you were given the function f of x is equal to 4 over x. You needed to find the derivative from first principles. Now remember, whenever you're doing the differentiation of a function by first principles, we set the formula out in a specific way. We say the derivative of f of x is equal to the limit as h approaches 0, as h tends to naught, of f of x plus h minus f of x all over h. All right, and this formula, remember, will then help you to find the gradient at any point on the curve. All right. So what you can do here, and I know that some of you do prefer to do it, you can do this formula, you can split it up into parts and you can find the function value of x plus h, and then you can subtract f of x and then divide it all by h. I'm just going to do it all in one step and in one line and just carry it through. So do follow along, but you are more than welcome to split it up and do them separately and then put everything back together at the end. Just be careful to not make any careless mistakes. Okay, the other question I often get asked, do I need to keep this limit as h tends to 0? Yes, you do. If you don't keep that, you've changed what it is you are finding. You're no longer finding the derivative of f of x at a specific point. All right, so we're going to do f of x plus h. What that means is wherever I see an x, I need to replace the x with x plus h. So find the function value of f of x plus h. So my f of x is now going to look like this. Wherever I see an x, so I see an x in the denominator, I replace that with x plus h. Okay, so f of x plus h will give me 4 over x plus h minus f of x, so minus the original function, which was 4 over x, and then we divide that by h. All right, so once again, take your limit along with you. So it's the limit as h tends to 0. In the numerator, you can now find an LCD and add your like terms. My LCD will be x times x plus h. I then multiply the 4 in the numerator of the first term by x minus, I multiply the 4 in the numerator of the second term by x plus h. All right, at this point, you're dividing by h. Now remember, division by h is the same as multiplication by 1 over h. So I'm going to write it like that to make my fraction look a little bit scary, because we know that fractions look scary when they're stacked on top of each other like that. So let's just get rid of that 1 over h. So my expression is now going to look like this. 4x minus, I multiply the 4 into the bracket. So I get minus 4x minus 4h all over. The h is now multiplied to the x and the x plus h that's already in the denominator. So it looks like this. And then we simplify. 4x minus 4x, those cancel out. So you're left with minus 4h over xh times x plus h. You can then cancel out your h's. Those are common in the common factors in your denominator and your numerator. So this is going to give me the limit as h tends to 0 of negative 4 over x times x plus h. Okay. The other thing you've got to remember is you cannot get rid of the limit as h tends to 0 or put an equal to, just the whole derivative of f of x is equal to, until you've actually then tended h to 0. So until you've substituted an h value of 0, you need to keep your right-hand side of your formula looking exactly as it does with the limit as h tends to 0 until you find a final value for your derivative at the point. All right, so at this point, from this line now, to get to the next line, I'm going to say, well, let's tend h to 0. As h tends to 0, it means that this term here will become 0. So I end up with negative 4 in the numerator divided by x times x, which is x squared. All right, so therefore the derivative of f of x by first principles is minus 4 over x squared. And guys, what I encourage you to do at this time, because remember you still know how to derive by rule, you can use deriving by rule to check that your answer for your differentiation is correct. So certainly take the original function 4 over x, derive that by rule, and you can just double check that your answer that you got from first principles matches. All right, so do a quick check. It doesn't take time to do that check. All right. The next question we're going to go through together. So once again, we're looking at differentiation. In this case, we're going to derive by rule. Let's read through the question. So here we are asked, and you can see we're saying dx. Remember, this is just a different way to state that you need to find the derivative with respect to x. What you need to remember here is you don't put equal to the final answer until you've gotten all of your terms inside that bracket derived. All right, so don't now start writing the answer down because it means you've already differentiated. Okay, so this is how we set this up. So I'm going to say this is equal to the derivative of x, and I'm going to simplify what's inside the bracket. So I haven't derived yet, so I still keep this dx, all right? To simplify what's inside the bracket, remember before you derive by rule, you need to get rid of square roots, and you need to make sure, or in this case cube roots or any surd, you need to get rid of your surds, you need to make sure you've got individual terms, and you need to make sure there's no x in the denominator. All right, so I need to rewrite the cube root of x squared. Remember from exponents, this will be the same as x to the power 2 over 3. So I rewrite the cube root of x squared as x to the power 2 over 3 minus a half x. So now I've got individual terms. I've got two terms. There's no surd sign, so no square root, cube root, fourth root, etc. And there's no x in the denominator. At this point, I'm now going to write equals to, and I'm going to write my answer in. So I'm going to start deriving. How do we derive by rule? We take the power of the first term multiplied by the coefficient, so that's the number in front of the x. I'm going to say 2 over 3 times 1, that gives me 2 over 3. And then from the x, from that power, you subtract 1. Okay, remember you're deriving by rule. It's your power multiplied by the coefficient of whatever your variable is, and then you subtract 1 from your power. Minus a half. X to the power of naught is, well, x to the power of 1. If we derive that, we're going to get x to the power of naught. How do I get that? 1 times a half is a half. X to the power 1 minus 1, which is 0. Okay, I can simplify this a little bit. 2/3 x to the power minus 1 over 3. So 2/3 minus 1 gives me minus 1 over 3. X to the power naught is just 1. 1 times minus a half is minus a half. All right. And that's how we derive that using the rules that we know so far. Okay. So, as I said, calculus is 25% of your exam. There's lots to get through. Make sure that each of those concepts is clear in your mind. You know how to derive by first principles, and you also know how to derive by rule. Okay, I'm going to give you a chance to look at another question. This comes from, once again, the same DBE June-July 2015 paper. And I'm just going to give you guys 2 minutes just to write down what it is you need, the key information you need from the question that's on your screen. Right, guys, I'm going to give you a few more minutes to try and attempt this question during the break. When we come back, we'll go through it together. Welcome back, everyone. Before the break, I gave you a chance to have a look at a question where you were given a cubic function and you had to show why the gradient of the tangent to this function will never be negative, okay? So let's understand conceptually what we are saying here. So you've got a function p of x, so it's a cubic function. They say, show using relevant calculations why it's not possible for a tangent drawn to the graph of p to have a negative gradient. So remember, a tangent obviously going to touch a graph at just one point. So I'm going to make a rough sketch of p of x. Okay, so that's our cubic function. We don't know where the tangent to the graph touches the graph. So let's just say it's at this point. Let's say it's somewhere there that it touches your graph. And you've got to then say, why is this? Why do you believe that this grade? Well, not why do you believe, because obviously there's a mathematical proof to it. But why is it that this gradient of this tangent will never be negative? So in other words, they're saying that the gradient to this graph is always going to slope towards the positive numbers. It's always going to have a positive gradient. How do we show that? Well, guys, remember that when the tangent meets your cubic function, or any function for that matter, the tangent and the graph, they meet at the same point and they have the same gradient. Okay, so your tangent and your graph is going to have the same gradient at the point of contact. And in calculus, how do we find the gradient of any graph or any function? What do? We have to find the derivative. So to show that the tangent drawn to this graph will not have a negative gradient, all I've got is the function p. I know that p of x is equal to x cubed plus 2x. In order for me to determine the gradient of the tangent, I know that the gradient of this function p of x will be equal to the gradient of the tangent at the point of contact. So therefore, I derive the function p and I get, using rules, derivative of x cubed will be 3x squared plus the derivative of 2x will just give me 2. Okay, so that's the gradient function, and that will be the gradient of the tangent at the point of contact. Now, if you look at this gradient function, 3x squared plus 2, you're always going to have a gradient that is greater than 2. How do I know that? Well, if you look at 3x squared, the fact that x is being squared will tell you that this function will always be greater than or equal to 0. All right? And then if you look at plus 2, that means that 3x squared plus 2 will also always be positive. It's always going to be not equal to 0, but it's always going to be greater than 0. So that function 3x squared plus 2 will always be greater than 0. In fact, it's always going to be greater than 2. So therefore, we've shown that any gradient of this function p of x is always going to be positive. And that's where you've got to leave it. This question was only worth 3 marks. So if you're struggling with a question like this and you're doing a whole page of work for 3 marks, go back, check yourself, make sure that you've read the question properly. That's so important in exam situations. Read your questions properly and only answer what it is that they've asked you for. Okay, so we've shown that this tangent will never have a negative gradient, so we can move on to the next question. This is quite a long one. This comes from the DBE November 2015. It's question 9 and it's from obviously Maths paper 1. Because it's such a long question, I'm going to give you time now to either find the question in your past papers or to take down the key information from the given information on your screen. I'll give you 3 minutes starting now. Right, guys, so this kind of question, these questions that build up to a point, you need the previous part to get to the next part. They are very common in exam papers. You need to understand that you've got to take each one. Don't look at the whole thing and say, oh my word, this is such a big question, and get really, really scared. You've got to deal with each question individually. Make sure that you go through it calmly and carefully and pick out the key information of what you are given so that you can answer the question effectively. All right, don't just look at the whole thing and then try and do everything at once. We need to go in order and have some sort of method when we approach these questions. So let's start by reading it. We are given that a function h of x, which is a cubic function, we can see that it's got two unknown values. It's got two variables, a and b. And we've got the line g of x, which is equal to minus 12x. We identify straight away that that's a straight line or a linear function. And we are told that P and Q has coordinates 2, 10, are the turning points of the graph H. The graph H passes through the origin, so that tells me both the x and the y intercepts at that point is going to be 0. Okay, so it passes through the point 0, 0. Show that a is equal to 3 over 2 and b is equal to 6. Now, you guys know by this stage that if you've got a function where you've got two variables which you need to calculate the values of, the only way to achieve that answer is to set up simultaneous equations. You can only solve for two unknown values by solving simultaneously. That means that they then need to give you enough information so that you can set up simultaneous equations, and they have given you enough information here. We know that the point Q is 2 and 10, and we also know that that's a turning point of H, and just in that they've already given you enough information to find A and B. So this is now 4.1. Let's just remind ourselves that Q is the main coordinate we're going to be focusing on. So I'm going to write that down. We know that that's a turning point. If you want to, you can make a rough sketch for yourselves. It's not necessary, but you can make a rough sketch so you have an idea of what's going on with the graph, all right? And so we've got that point. We've got that h of x is minus x cubed plus ax squared plus bx. All right. So using the point Q, which is a point on the graph, and the turning point, I can set up simultaneous equations in the following way. Now, firstly, because Q is a turning point, I know the derivative at the point 2 must be equal to 0. How do I know that? Well, you know that whenever, and I mean you guys should know this by now, that whenever you're trying to find the turning point on your graph, it's where the gradient of the graph is 0. All right, so using the fact that they've given you Q and they've given you the x value at that point is 2, the y value is 10, you know the derivative at the point 2 must be equal to 0. Okay. And what I'm going to do to make it a little bit easier for you guys, before I substitute the 2 in, I'm going to find the derivative of the graph h of x. So derived by rule, I get minus 3x squared plus 2ax plus b will be the expression for my derivative. I know that the derivative when x is 2 will be 0 because 2, 10 is a turning point, the point 2 and 10. So I now substitute, I replace the x value with 2, and that will give me one equation in terms of a and b. So I'll get the following, minus 3 times 2 squared plus 2a times x, which is 2, plus b. So 2 squared is 4. 4 times negative 3 is negative 12. Plus 2a times 2 is 4a plus b. And what do we know that this is equal to? We know that this is equal to 0, which is great because I've now got one of my equations that I'm going to use. So I'm going to call this equation, which I'm just going to rewrite, 4a plus b minus 12. I'm going to call that equation 1. Where do we get equation 2 from? Remember, the point 210 is a function value on this graph. So when your x value is 2, the corresponding y value is 10, right? So now we're dealing with the function value. Do not confuse the function value with the derivative of the graph at the point 2, okay? So h of 2 now, not the derivative at the point 2, but h of 2 is equal to 10. So this is going to give me my second equation. I replace x with 2 in the original function. So this is what I'm going to get. Minus 2 cubed plus a times x squared plus b times x is equal to 10. Okay, and you see what I've done? Wherever there was an x, I've replaced it with a 2. So I end up with negative 8 plus 4a plus 2b is equal to 10. I'm going to rewrite this equation by bringing everything over to the left-hand side. So I have 4a plus 2b. When you take your 10 over to the left-hand side, you get minus 10 minus 8 is negative 18 is equal to 0. But you might be saying to yourself, but why are you writing it in that way and you're not doing a substitution? You can, if you prefer, you can solve your simultaneous equation by substitution, or you can do the method of elimination. I'm going to use the method of elimination because I've noticed here in both of these equations, equation 1 and 2, I've got a 4a, and it's going to be very easy to get rid of that 4a. All right, so we're going to do it in the following way. I'm going to say equation 2, and it doesn't matter if you say 2 minus 1 or 1 minus 2. Equation 2 minus equation 1, and you'll get this. We set them up vertically, remember, on top of each other. So we get 4a plus 2b minus 18 is equal to 0. Equation 1, 4a plus b minus 12 was equal to 0. Okay, remember when we subtract, we have to change our sign. So in our second line, we're going to change all our signs to negative and positive. So we change whatever the sign was, we change it to the opposite thing. It's basically multiplying. What you're doing here is you're multiplying equation 1 by negative 1. All right, and that's how you get all those sign changes. When we do that, 4a minus 4a, do you see that variable cancels? So now all I'm left with, 2b minus b is just b. Minus 18 plus 12 is negative 6. So therefore you get b is equal to 6. And at this stage, I'm really excited because that is exactly what they asked you to show. They said, show that b was equal to 6, and they said show that a is equal to 3 over 2. Once you've got the value of b, you're going to substitute that now. So b is equal to 6, substitute that in either equation 1 or 2. I'm going to use equation 1 and solve for a. So we end up with 4a plus b, but remember b was 6, so I replace my b value with 6. Minus 12 is equal to 0. And I solve for a. So I get 4a, 6 minus 12 is negative 6. Take your 6 over to the right-hand side, divide through by 4, and you get that a is equal to 3 over 2. Quite a long process. Simultaneous equations always are, and that's why it's worth 5 marks. But the actual simultaneous equation itself, you've been practicing that since grade 9. It's not a difficult concept. Be very, very careful that you don't make any silly mistakes. So now that we've got the values of A and B, I want you to keep those values with you as we go into an ad break, and you continue to try question 4.2. When we get back, we'll go through 4.2 together. Welcome back, guys. I hope that you've been following with us and you understand exactly how to get your values for A and B that we looked at before the break. That was question 4.1. And now all I've done during the break is I've just written out what the equation h of x is going to look like. I've replaced the value of A with 3 over 2, and I've replaced the value of B with 6. So that's what your function h of x looks like. All right. Please remember that if you were unable to get those values for a and b, so say you made a mistake somewhere in that simultaneous equation, assume those values for the rest of the questions. So you just take those values that they gave you, because they said show a is 3 over 2, show that b is 6. So you know those are definitely the values for a and b. Just take them, put them in, and carry on with the rest of the remainder of question 4 in this case, all right? So just assume the values, carry on, and then later on you can go back when you have time and check where if you did mess up your simultaneous equations and didn't get those values. All right. So this is now question 4.2. They say calculate the average gradient of h between p and q if it is given that x is equal to -1. So you've got p as one of your turning points. You've got q as the other turning point. They're asking you to find the average gradient between those 2 points. It simply means find the gradient of the straight line that can be drawn between those 2 points. All right. So you know that in order to find an average gradient, it's y2 minus y1 over x2 minus x1. That doesn't change. It's the exact same thing here. All right. They've given you that the x value at point P is -1. So to find the function value, we need to take that value of x is -1, substitute it in place of x, and find out what the y value is at point P. So it's going to look like this. So this is 4.2. To find our function value, it will be the function value at the point F. All right, let's do it like this. So it's the function value of h, so it's the function value at the point Q minus the function value at the point P, all divided by the x coordinates of those points. So x value at point Q minus the x value at point P. All right, we just need to work out what the value, the function value of h is when x is equal to -1. So all I'm going to do there is I'm going to say h of -1 is equal to, and then we substitute and find out. So we're going to replace x with -1 in h of x. So we get the following. -1 cubed plus 3 over 2 times -1 squared plus 6 times -1. Plug all of that into your calculator. I know that all of you know how to do that by now. When you do that, you will come out with a value of -3,5. So we've got the coordinates of the point P are -1 and -3.5. Okay, we then find our average gradient by doing the following. So the average gradient will be equal to 10, which is the y value at point Q, minus the y value at point P. All right, that's just supposed to be a negative there. Divided by the x value at point Q, which was 2, minus the x value at point P. All right, again, all of this calculation you can plug into your calculator and you'll come out with the following. You'll get that the average gradient is 4.5. Okay, guys, let's move on to the next one here. So now here they're talking about concavity. Show that the concavity of h changes when x is equal to a half. So remember what you're doing here is you need to show, when we're talking about concavity, we need to start talking about the second derivative. So I need to find the value of the second derivative or the expression for the second derivative, and I need to show that the sign of that changes at the point x is equal to a half. So I need to look at values less than x is a half and then greater than x is a half, and we need to show that your graph's going to be concave up and concave down after the point. So concave up perhaps before and then concave down after the point a half, and therefore your concavity will change, or the other way around. We're going to check now and see whether we're going to go from concave up to concave down or concave down to concave up. The first thing we need to do is to work out the second derivative. Okay, so this is 4.3. We know that h of x is equal to negative x cubed plus 3 over 2 x squared plus 6x. So my second derivative, my first derivative would be negative 3x squared plus 3x. Remember, you multiply by your exponent. We multiply the coefficient 3 over 2 by 2, and so we get 3. And then from the exponent 2, we subtract 1, so we just get x to the 1 plus 6. Okay, so that's my first derivative. My second derivative, which is going to give me a clue about the concavity, we derive the first derivative. So I will get minus 6x plus 3. So that's the expression for your second derivative. Now remember, what you want to find out is what's happening around the point a half. Okay, so let's say that that's our number line, and I've got the point x is equal to a half. I want to know what's happening to the right of that and what's happening to the left of that point. All you've got to do, guys, is you take any value that lies to the right of the point a half, put that in place of x in your second derivative and see what the sign is going to be. You can take any value, it will work for any one of them. So I'm going to find the second derivative, say when x is equal to 1. So I'm replacing x with 1, and I'll get negative 6 plus 1 will just times plus 1 will give me negative 6 plus 3. So that gives me a negative answer. And it will work for any value. Even if you try 10 or 20, whatever value you want greater than a half, it will always give you the same. What we're interested in is the sign of the answer. So obviously you're going to get different values for your second derivative, but the overall sign will always be negative. So we can see that any point to the right of x is equal to a half will give us a second derivative that's negative. So it will be negative for any point greater than a half. So that tells me I'm looking at a concave down part of my function. And then we look for anything below a half. So here you can take 0, you can take 1, put in any value. Again, your sign will be the same. So let's put in 0. We'll get minus 6 times 0 plus 3. What we're interested in is the overall sign. So overall, our sign is going to be positive. Okay, so that's really what we're interested in. So that means any point to the left of x is equal to a half on this graph is going to have a positive second derivative, which means your graph is going to be concave up. So because your concavity changes from concave up to concave down, this point x is equal to a half will be, all right, well, I'm jumping ahead of myself here, but just they say here, show that the concavity of h changes. So what you'll say at that point is because the graph goes from concave up to concave down, it means that the concavity changes at the point x is equal to a half. All right. The next question is now related to this one. So 4.4 says, explain the significance of the change in question 4.3 with respect to h. So remember what we're saying here is what is the significance of this concavity changing at that point? Well, that means that this point x is equal to a half will be a point of inflection. Okay, because your concavity changes, x is equal to a half will be your point of inflection. If you wanted to go further, you could find the second derivative at the point of a half, and you could show that it was in fact equal to 0, and therefore x is equal to a half will be a point of inflection. I quickly want to look at the last part of this question so we can hopefully squeeze it in before the end of this lesson. Determine the value of x given that x is negative at which the tangent to h is parallel to g. Okay, so this is what we've got. So we were given this equation g, which we haven't really used up until now. All right, so let's just get our page extended a little bit. So we've been given this graph G that we haven't used until now. This is what they're saying. So we've got the graph of H. They're saying you need to determine the value of X at which the tangent to H is parallel to this line G. So you've got this line G of X, which was equal to negative 12x. So G of X was given as negative 12x, all right? So therefore, if G of X is equal to negative 12x, that's going to be a line that doesn't touch this graph H of X, but that line is going to be parallel to the tangent of the graph H of X. So if you've got G of X, let's just draw it in a random place. Let's just say it's going somewhere here. Okay, then you've got another line that's a tangent to the graph and parallel to that line G. So there's going to be a line that touches the graph that is a tangent, and it's going to be parallel to this line G. The most important thing that tells you then, remember that if straight lines are parallel, they have the same gradient. So the gradient of the tangent is going to have a gradient of negative 12 because it's parallel to G of X. So to find this point now, all we're going to do is we're going to say, well, the derivative of H of X is going to be equal to the gradient of the tangent at the point of contact. So therefore, negative 3x squared plus 3x plus 6 must be equal to negative 12 at the point of contact. And we're going to solve for x, all right? So we're going to get the following. Minus 3x squared plus 3x plus 6 plus 12 will give me positive 18. You can then divide through by negative 3 and you'll get x squared minus x plus 6 is equal to 0. And then you can factorize that. So you get x minus 3 times x plus 2 is equal to 0. And remember, the question said that the value for x is negative. So therefore, you're going to get x is equal to 3, which is not applicable. And x is equal to negative 2 is the one that we are interested in. So x is equal to negative 2 only will be the value that this tangent line is parallel to the line G of X at that point when x is equal to negative 2. All right. Guys, that's a lot of work that we covered in today's lesson, and I know that this is going to help you as you start your revision for calculus. Hopefully by now you've started revision on calculus a long time ago. Good luck with the rest of your revision, and until the next time, keep practicing.